Right, so welcome to Unit 15. And in Unit 15, we're going to do a bunch of different functions that are more advanced than the simple linear straight line functions and quadratic functions, right? Those with x squared that made parabolas. And the first one we're going to do is called a piecewise function, and it's got a good name because it has several pieces. So we're going to plot both the functions 2x plus 4 and negative 2x minus 4. Hopefully we all realize that those are linear functions that are going to make a straight line. So y equals 2x plus 4 starts at 0, 4, has a slope of 2 over 1 and up 2. I'll put a few more points here. There's the x-intercept. And that's that linear function. Then on the same graph, we're going to plot negative 2x minus 4. So it's got a y-intercept of 0, negative 4, and it goes down 2 and over 1. Interestingly, these have the same x-intercept. Now, normally when we plot things like this, we're trying to find this point of intersection, but that's actually not what we're doing here. I'm just practicing linear functions here. And we're also going to remember how to do an inequality. Let's see if you can remember how to read that. That is, x is less than or equal to negative 3, or x is greater than 5. So we have to find negative 3, closed circle on negative 3, and we need the numbers less than negative 3 as well as negative 3 itself. X is greater than 5, open circle on 5, and that's a typical or inequality, right? They point out. Right, so this is what a graph of a piecewise function looks like. And you'll notice that we have the open circle, closed circle business. That's what we just reviewed. And notice that when the x value is less than 0, we have one function. This section is when x is less than 0. Y has a bunch of different values, but over here on this side of the y-axis is x is less than 0. Over here is x is greater than or equal to 0. I said greater than or equal because that's a closed circle. And there's a bunch of different y values over here, but that's the graph for x is greater than or equal to 0. This is called a piecewise function. So a piecewise function has two equations on the same graph. Each piece applies to a different part of the domain of x, right? Domain is x. So let's read this. It says evaluate the function for x equals negative 2. So f of x equals negative 2x if x is less than 3. It equals something totally different. There's another piece to the function if x is greater than or equal to 3. On that section, it equals x plus 4. All right, so x equals negative 2. Is negative 2 less than 3 or greater than or equal to 3? Well, it's less than 3. So f of negative 2 equals negative 2. This is that negative 2. And then we're putting this negative 2 in there. And we're f of negative 2 equals 4. We evaluated that function. Notice, if you put negative 2 over here, you get a different number. But the function doesn't read that way. All right? If you put negative 2 in, you pick from that one. You don't pick the other one. So now we're going to evaluate that function for x equals 7. So 7 is greater than or equal to 3. It's greater than 3. So we're going to put it in that one. So we say f of 7 equals 7 plus 4 equals 11. Again, if you put 7 in the other one, you get a number, but that's not value. This function is in pieces. It's a different function depending on which x value, where you are on the coordinate plane for the x values. All right, so equals 3. Well, same one because x is greater than or equal to 3. So f of 3 equals 3 plus 4 or equals 7. this is a piecewise function. There are different pieces. All right, so let's try this again. Evaluate the function for x equals -4. Pause and do that. All right, so equals -4. So we're here. So we're doing f of -4 equals 1/2 times -4 plus 6. Half of -4 is -2, right? And -2 plus 6 is 4. So f of -4 is +4. So now we're going to plot the linear functions that you've been seeing. We evaluated them. That seemed pretty simple, hopefully. And you're going to need to graph things and then erase them probably. So do not try this in pen. So let's start at x equals 3. All right, it says x is less than 3. So x is 3. If x is 3, all right, we're doing this graph -2x. All right, so let's graph, right, y equals -2x. So everyone graph y equals -2x. So hopefully you went to 0, 0. You went down 2 and over 1 for -2x. Now I have a lot harder job than you because actually I don't have a pencil. So I have to think about this ahead of time. So let me just look at this. And I did a horrible job. Let's try again. I'm going to try again here. So here, and then this way. Okay. Now, the problem, I just graphed this for all values of x, but I only want it for the values where x is less than 3, right? So there's x is 3. So I only want this side of the graph, right? So I'm going to erase the other part. So I'm going to erase this part. And since it's less than, I'm going to put an open circle right where x equals 3. Okay, so now I'm going to graph the other one. I'll use a different color. And it says y equals x plus 4. So graph that the normal way, but you're going to have to erase part of it. It has the y-intercept of 0, 4. It has a slope of 1. Okay, so we're doing that. And once again, that's the graph of y equals x plus 4, right? But we only need the part where x is greater than or equal to 3. So that's this section over here. So we're going to erase this part over there. And we're going to put a closed circle on it this time. And then we're going to clean up our stuff. And you get a graph that looks like this. Notice there are two separate parts to it. When x is 3 or bigger, you're on this ray, right? A ray has an arrow on one end. And when x is less than 3, you're on the other ray. You have different values of x. Oh, there, I graphed it already. And I used opposite colors when I did it myself, but there it is. Oh, I put my closed circle here. Did I put it? Yes. All right, so try this one. So the border is -4, right? So we're going to have two different lines going in different directions. So let's graph the top one, y equals 1/2 x plus 6. Y-intercept 6, slope of 1/2, over 2 and up 1. Right, that's this one. And now, as you get to be an expert at this, can you not draw the whole thing, only draw the part you need and not erase? Of course you can, but I'm just drawing. That's what y equals 1/2 x plus 6 equals. We only need the part over at left, right? That's on this side of -4, right? So we're going to erase all this on the other side. We don't need any of that. And since it's less than or equal to, we're putting a closed circle. All right, do the other one, pause. So this is y equals 2x, right? I'm using y instead of f of x. And so y equals 2x. So 0, 0 is the y-intercept, slope of 2. Right? I need to be conscious of where my border is. It's at -4 this time. Oh, that was horrible. Let's try again. So that's what y equals 2x looks like normally. But we're getting rid of the part where it's less than or equal to -4. So we need an open circle right there. And that is our new graph if we clean it up. And did I graph that? Yeah, I did. Yes, I got the same answer twice. That's always a good sign. And circle there. There it is. So let's write a piecewise function for this graph. We're going to work backwards. All right. So what you do is you write f of x equals, we're going to braces here. Now, we have a border this time of x equaling 0. Right? On this side, this is if x is greater than or equal to 0. Greater than or equal to because of the closed circle. This one is if x is less than 0. We're just looking at the x coordinate over here. All right, so now find the y-intercept there. Find the slope over there. This looks like a slope of 3. All right, so we're going to write the function for x is greater than or equal to 0. Don't write the y because we already have f of x over here. So you're going to write 3x minus 4 if x is greater than or equal to 0. Okay, now do the other one. Y-intercept of 0, -3. Now this is a slope of -1/4. So this part is -1/4 x minus 3 if x is less than 0. All right, so the domain and range are coming back, right? The domain is all the x values, the range is all the y values. Well, here's the x values that are possible, right? It's the possible x values. We said x could be greater than or equal to 0 or less than 0, and that includes all fractions and decimals. So the domain here is all real numbers. The range, as often is, the range is not all real numbers. Look at it. Notice that both arrows point up. So there's no way y is getting lower than 0, -3, right? There's no way you can get a y value down here anywhere. So what's the range? The range is y is greater than, and it's not or equal to because it's an open circle, so less, y is greater than -3 is our range. So we can write the domain range as an and or an or inequality, and let's see that. Let's write a piecewise function for this. So it's f of x equals, we have our brace, we have if here and if here. The border this time seems to be x equals -4. So we can have a part that's x is less than or equal to -4. We're going to have another part that is if x is greater than -4. Right? -4 is our border between the two pieces. Now, let's write that now. This is much harder, right? Where's the y-intercept? This is not the y-intercept over there, right? It was the last one was easy because the lines intersected the y-axis. So you're going to need a straight edge for this. So we're going to extend the line. You're going to take your ruler, your straight edge. Yeah, you need a straight edge for this. And right, that would have intersect, the y-intercept of that function is over at 0, 5, right? This one's much harder. You're going to have to figure it out. Okay? So let's figure that out. But we'll start with the top one. You should be able to write the function for the top one. So we're going down 1 and over 2. So down 1 and over 2, that's a slope of negative 1/2. So this is f of x equals negative 1/2 x plus 5, right? If x is less than or equal to negative 4, right? So we had to extend this out to find the y-intercept. Now, before you find the y-intercept, find the slope here on the bottom one. So we're down 2 over 1. Whoops, no, we're not. Well, that is not down 2 over 1. Down 3 over 1. There you go. So we went down 3 over 1. So now we're down 3 over 1 there, and we're at negative 11, right? So what if we go down 3 and over 1 again? We'd be at negative 14. And if we go down 3 and over 1 again, we'd be at negative 17. The y-intercept is 0, negative 17. Now, I didn't draw it that accurately, but right, we started at negative 5, went down 3 to negative 8. So we must be going down another 3 to get to there, and then another 3 to get to there, and another 3 finally takes us to the y-axis. So this function has a slope of negative 3 and has a y-intercept of negative 0, negative 17. All right, much more difficult. So this, by the way, before we do the domain and range, they're pointing opposite. So it's an or inequality. They're pointing away from each other, okay? And the other one where they're pointing in the same, no, I don't want to say that, but this one is an or inequality. So let's find the domain. So the domain here, what could x be? Well, x could be x is less than or equal to negative 4, x is greater than negative 4. That's all real numbers again. And the range is interesting. This is where our and or is coming in. We have a gap, right? We have a gap here. X can't be in that section, right? Because the bottom one points, y can't be in that section because there's a gap between those two rays. One's pointing down and one's pointing up. So it seems like, let's start with the one on the bottom. Y could be less than, open circle, negative 5. There it is. Or, and I'm saying or because they're pointing in opposite directions, like I said. Let me make this a little neater. And then this one is y is greater than or equal to, because of the closed circle, positive 7, right? It's an or inequality for the range. All right, so that's the lesson. Let's practice it. So plot this piecewise function. Yeah, when the border is 0, makes life way easier than the one you just did. The top one, y-intercept of 0, negative 5. Slope of negative 1/2, down 1 over 2. We only need the part where x is less than 0. So if you want to just skip the other part, that's fine. We only need that part. We don't need over here, right? Because that's x is less than 0, and I should be putting an open circle there. And mine's not all that perfect because I should be hitting, if I'm going every 2, I should hit right there. So I'm going to fix mine. The bottom one is a y-intercept of 0, 3, and a slope of 2, over 1, up 2. Again, you only need the part greater than or equal to 0, so I already have a nice closed circle there. And there's the graph of that piecewise function. Are we going to ask the domain and range? I think we are. Oh no, I'll evaluate the function for x equals -4 and plot the point on the graph. All right, so let's do that. All right, so this is what we started with. All right, so -4 is in this section, less than 0. So we're f of -4 equals -1/2 times -4 minus 5. I'm using this one. -1/2 times -4 is +2. 2 minus 5 is in fact -3. So let's see if we can plot that point on the graph. Let me clean things up here a bit. There's the graph. And so when x is -4, right, y is -3. Up there it is, right? -4, -3 is one of the points in this piecewise function. Notice if you put -4 in the other equation, right, you're going to get something, that is not on the graph. Let's do that. So you get 2 times -4 is what? -8, and -8 plus 3 is -5. So you get this point -4, -5, but that's not on the other section. It's not on any section. So make sure you're evaluating it correctly, right? We're only evaluating that piece. All right, so we're going to work backwards and write a piecewise function for this. The top one's fairly straightforward. You can see the y-intercept, right? The y-intercept is not the border line, right? The y-intercept where it crosses the y-axis, right? It's where it crosses that thing. They're nice and easy when the border is also on the y-axis. Okay, now the other one seems to have a slope. Now this is a slope of +3, even though it's pointing down, right? If you graph this linear function, that have a slope of +3. So it's going to start with 3x. Well, now we have to get the y-intercept, and let's use blue just so that I have a different color here. All right, so it's slope of 3, right? So we're going over 1 up 3, over 1 up 3, over 1 up 3. There it is. That's where the y-intercept would go. And you could do this also by just extending a line with a ruler. And so this is the other one. Let's do it in blue. It's f of x equals 3x plus 8. Let's clean this up a bit here. Okay. All right, now we're doing domain and range. Domain, range. Okay, now let's see what the x values could be. X values could be anything, all real numbers. This one, all right, so notice everything is pointing down here. Okay, so there's no way you're going to get a y up there. So y has to be less than or equal to 5, right? That's the highest, right? The y-intercept is 0, 4, but the highest y value here is this -2, 5. That's what it looks like. So y can be less than or equal to 5. And notice these are pointing in the same direction. So, all right, final question. Plot this. The border is 3. Now, the top one starts at 0, -5, and has a slope of -2. Slope of -2. And so to get over there, I'm below the graph. And that I need x is less than 3, so it's going to be this way. So this is -2x minus 5. I'm going to give myself a few more points here. So that's for x is less than 3. I need an open circle there. Let's clean this up a little bit. All right, there's our y-intercept of 0, -5. We have to go down here, down to this point at, what, 3, -11 is where it transitions, and we need a closed circle there. Okay, now the other side. X plus 4, so y-intercept of 0, 4, slope of 1. And again, we only need the part that is greater than or equal to 3. So closed circle there, and we have graphed our piecewise function. Domain, range, domain, all real numbers. X could be anything here. And then the range, what could y be? Oh, they're both pointing up again, so it's the same idea. And so the y is greater than or equal to, closed circle down here, open circle down here, less than 3. This is an open circle. So y is greater than -11.